Hi everyone, and welcome to the fifth video in the Weather Unlocked video series. This video is going to go over air masses and the boundaries that separate them. So what is an air mass? An air mass is a large body of air with generally uniform temperature and humidity characteristics. Now the area that an air mass originates is what's going to provide its characteristics, and this is known as a source region. Now the longer an air mass stays over its source region, the more likely it'll acquire the properties of the surface below. So looking at the moisture and temperature qualities that make up air masses, we can then determine its characteristics. So first, starting with the moisture contents, there's two different types of air masses. First, we have the continental air masses, denoted by a lowercase c. Now these air masses originate over the continents and are therefore the dry air masses. We also have the maritime air masses, denoted by a lowercase m, which originate over the oceans and are therefore the moist air masses. Now, each of these two moisture air masses can then be divided based on the temperature content of its source region. For example, we have the Arctic air masses, denoted by an uppercase A. Now, these air masses originate over either the Arctic or the Antarctic regions and are therefore considered very cold air masses. Now, we also have the polar air masses, denoted by an uppercase P, and these originate over the higher latitudes. Now, they aren't as cold as the Arctic air masses, but they're still considered pretty cold or cool air masses. And finally, we have the tropical air masses, denoted by an uppercase T, and these originate over the lower latitudes and are therefore the warm or hot air masses. So now let's combine both the moisture and temperature contents. For example, we have the continental Arctic air mass, which is very cold and dry due to it originating over the poles. Next, we have the continental polar air mass, which is not as cold as the Arctic air mass, and it's very dry. We also have the maritime polar air mass, which is also cold, but it's moist due to originating over the ocean. Now, typically, the desert air masses are the continental tropical air masses due to them being hot and dry. And lastly, we have the maritime tropical air mass, which is hot and moist. Now, as these air masses move around the Earth, they can then begin to acquire additional attributes. For example, in the winter, if a continental Arctic air mass or a very cold and dry air mass moves over the ocean, it's then going to start picking up the warmth and moisture from the warmer ocean, and that can lead it to becoming a maritime polar air mass, which is still fairly cold, but it also contains moisture. As another example, if that same polar air mass moves south from Canada into the southern United States, it'll then pick up some of the warmth of the ground. However, it's still going to remain fairly dry, so it's going to then become a continental polar air mass. There's also several different boundaries that can separate the different air masses. For example, with a cold front, a colder air mass is replacing a warmer air mass. On the opposite end, with a warm front, warmer air is then replacing colder air. Now there's also what's known as an occluded front, and this is where the cold front catches up to the warm front. Next, we have the stationary front, which, as the name implies, means the boundary between the two air masses is stationary, or it doesn't move. And lastly, we have what's known as a dry line, which divides moist air from dry air. Now, the next video in the Weather Unlocked series is going to look deeper into the different types of fronts and boundaries that separate the air masses. So that concludes this video on air masses, and make sure to stay tuned for future videos in the Weather Unlocked video series.